Okay, ladies and gentlemen, we're moving on to the third and the last major part of this topic, and it is deposition. So again, quickly taking a look at this background picture here. We have the mountains, we have lots of weathering going on. In fact, look at all these nice U-shaped valleys created by the glaciers that are in between, right? And you could see all of these things here that are slightly different colors are your sediments that have been weathered and eroded down. Right? Now, the last part is deposition. So, what is deposition? Well, deposition is kind of what this word means here, right? Deposit. What does it mean to deposit? Deposit means to, like, if you're depositing money in a bank, you're going to the bank and you are depositing it. You are dropping that money off. So the word sedimentation or deposition means the same thing, right? It does involve sediments, right? And this is where the sediments are released, settled from, or dropped from some sort of erosional system. So picture a very fast moving stream. The stream is carrying particles with it. As the stream starts to slow down, it can't hold the same amount of particles. Those particles are then dropped off, right? And we get deposition. Right? We could see it here in this picture on the right. Here is the river. The river is flowing this way, right? And even though this water here is kind of brown, notice that this brown, or what looks like sand here, creates like a beach. Right? This isn't a beach. This is actually the mouth of the river, right? And this is all the sediment that has settled out of the water because the water is moving fast this way, but it hits this area here and it slows down and it drops those sediments off. Right? And then you can see this looks like nice water out here, right? But this is just shallow water with lots of sediment in it. All right, so when we think of deposition, there are three major things that are going to affect how something is deposited. The first thing is going to be the size of a particle. So ask yourself, if I had two different sized particles, a big particle and a small particle, and I dumped them in, let's say, a container of water, what's going to hit the bottom first? Well, should be pretty obvious, right? The largest sediments are going to settle out first because they are heavier. Bigger the particles, the faster they are going to settle. So let's take a look at that. So here we have particles that are all the same density, but they're going to have a different size. So large, medium, and small, and we drop them in at the exact same time. You can see the largest particle made it to the bottom, followed by the medium one, and then the smallest one last. Bigger particles, faster settling rate. Okay. The second thing is going to be the shape of a particle. Right? Now, we've all seen this before. How many of you have ever dropped a sheet of paper onto the floor? Right? As it falls off your desk, does the paper go right down to the floor? No, it kind of flutters and moves back and forth, kind of like this before it hits the ground. Now, if you take that piece of paper, crumple it up into a ball, and now drop it, it's going to go whoosh, shoot right down to the bottom. So round sediments are going to settle out first. The flattest sediments will be last because they encounter more resistance. Right? The faster they settle, the rounder they are going to be. So let's take a look at that and see how that works. Right? So now same density, but we have different shape. So we have the flat particle and we have the round particle. Again, we drop them in at the exact same time. The round particle shoots right through the water, makes it to the bottom, but the flat particle kind of tumbles through. It doesn't go straight down to the bottom. And if we see it, the flat particle kind of wavers side to side because it's tumbling. So the rounder the particle, the faster it's going to make it to the bottom. And the third thing is density. We tend to always forget about density, but the higher the density, the faster it is going to settle. All right? Higher density generally means if all the particles are the same size, you have a much higher weight, meaning they're going to settle faster. So let's take a look. All right, now we're going to have different densities, but the same shape and size. So notice all three of these marbles are the same size. They're three different colors, so we can see we have high density, medium density, and a low density. And when we drop them in the water, the high density one shoots right to the bottom, followed by the medium one, and lastly, oh yeah, there it is, the slowest is the low density. So again, The greater the density, it's going to shoot right down to the bottom. Right? Less dense takes more time. Okay, so we can see that these three things are extremely important in determining how something is going to settle out. Now, what does that mean? Well, I took a look at the animations. So now we have something called vertical sorting. Right? So this tends to happen in not rivers, in lakes, in like the ocean, all right, ponds. If you took a handful of sediments, if they were all mixed up in different ways and threw them into the water, what's going to settle out first? Well, this goes back to those three things that we just talked about. The largest, the most dense, and the roundest sediments are going to make it to the bottom first, and then it's going to work its way up. So vertical sorting kind of looks like this. It's also sometimes known as graded bedding, right? Where you have your biggest, roundest particles on the bottom, followed by your medium ones, your smallest ones, and then your absolutely tiny, tiny, tiny little ones. Now, what happens here, right, is you can have this happen over and over again in different erosional systems. So let's say that you drop the handful into a fish tank. This is what you're going to get for the first settling. Then if you took another handful, dropped it on top of it, you're going to have the bigger one settle on top of what was already there. So what I want to do is draw this. So I'll show you what it looks like, and then we're going to draw what this animation is going to show us. So I'll jump to the animation. We can see it. So here's vertical sorting. If we have a container of mixed sediments and I dump them in, here they go. The ones that make it to the bottom first are going to be your biggest ones, followed by your medium, right, and your smaller, and then your smallest on top. Biggest, and then you get smaller as you go up. Now, do it again. All right, here's your second handful. You drop it in again, it repeats itself. So you have very nice layers of sediments. This separation here, when you go from small to big, allows you to see when different erosional systems or have different events. Right? It could be, you know, two different times that people were working on an area and they're dumping sediments into a pond or the ocean. Happens all the time. So let's draw this. So we're going to start, right? Come here on the bottom, and you're going to draw your largest sediments here on the bottom, and draw like 5 or 6 of the biggest sediments. Right? Then, right, on top of that, you're going to have smaller ones. Right? This is, more of your medium-sized sediments, kind of something like this. Right? You want to make them small, and again, I apologize, my writing is not the best here. Right? Now you're going to come again and draw even smaller ones. So these are going to be your smallest type of sediments on top, kind of like this, go across. All right, and then on top of that, you'll have your smallest ones. So these are just going to be your really tiny particles. Just put a bunch of dots on top of that. All right, so this is the first time. Right, that's your first handful. Now, let's draw the second handful. So we're just going to repeat it. Draw your biggest ones on top. And again, I apologize. Right, biggest ones on top like that. Then you're going to draw your medium ones. Like that. Right, then you're going to have your smallest, or smaller ones, sorry. Kind of coming across. Right, and then lastly on top are going to be your absolute finest particles. Right, and this would be 2. And it could go on and on and on and on. That is vertical sorting. Right? In fact, if you actually go out in your backyard and you dig down in the ground, you'll see probably one event like this. Your biggest stuff, smallest stuff, and then your smallest dirt on top. So that takes us to our next one, which is horizontal sorting. Now, horizontal sorting occurs when rivers meet lakes, ponds, or oceans. So what happens here, right? The stream starts flowing on this side. This is where the water is moving the fastest. Right? So side over here, this is still the stream, so the water is moving fast. But as the stream flows into, let's say, a lake or the ocean, once it hits that really deeper water, it starts to slow down, it loses energy. So we can't carry the same size particles. First ones that get dropped off are your big ones, and then you slowly work your way down smaller. Now notice the sizes: boulders, cobbles, pebbles, sand, silt, clay. Those words should sound familiar. We're going to take a look at them again in a minute, but these are the particle sizes that were listed on that streamflow chart from the reference tables. So now, here's what horizontal sorting looks like. Here's your river, and it flows out this way. And once the river starts to slow down, you get all of these sediments in this whole area dropped off. This is what is known as a river delta, right? River delta tends to have really fine, soft sediments. So let's take a look at how this works in an animated way. So similar, right? The stream flow is this way, and we can see your biggest particles are up here where you have a high velocity or a high speed, right? And then as it flattens out, the speed starts to decrease, right? And then down here where you have your gentlest slope, right, or gradient, and a lowest velocity, meaning lowest speed, you get your smallest particles. And notice these black things, right? Those are your small, really particles that stay suspended and can flow all the way out. So let's draw horizontal sorting. Let's draw horizontal sorting. So here is your horizontal sorting. So first thing that we want to do is let us draw the ground. So we're going to go kind of like this, kind of swoop it out, right? And I'm going to go like that to show the direction of flow. Right, so the water is flowing in that direction. Now, we're going to go, and up here where the water is moving fast, we're going to draw our biggest particles, right? And as you move away from this, slowly make your particles smaller and smaller and smaller and smaller and smaller until the ones that you have here are nothing but little specks, okay? So up here, you've got your big particles, right? Down here, you have your small ones, right? And the reason why you have your big particles up here, because the water is moving fast. I apologize for the handwriting, right? And down here, you have your smallest particles because the water is moving slow. It slows down, right? If you want, you can even add a nice fish in there to show you that this is kind of like a stream, right? There's my fish. Make it a shark. Right? There you go. That's my artistic ability for you. Okay? So, fast moving water, big particles. Slow moving water, small particles. All right? Now, where do we see that? Well, we see that. All right? And I'm going to go back. Sorry, I kind of jumped ahead. But when we take a look at glaciers, which we will get to in a little bit, right? There are a couple of questions at the end, and it's all I want you to do is try answering those questions using this stream flow chart right here, and it works the same way. For example, if you have a particle that is 0.1 centimeters in size, how fast the water must be moving to carry it, you're going to go over to here, you hit the graph, right? And then you go straight down, and it would be about 5 or so centimeters per second. That's how that works. Okay, again, that takes us to the end of erosion, weathering, right? And finally, this was deposition. If you have any questions, please feel free to reach out to me on Teams or on Remind and ask.